All right, so today we're going to be looking at two special types of quadratics that have some special characteristics whenever we factor them. So the first one that we're going to look at is called the difference of perfect squares. And to actually notice this one, we're going to start by doing some multiplication. So I want to know what happens when we multiply the following. Okay, so I'm going to distribute the x and the negative 3. So x times x will give me x squared. X times 3 gives me plus 3x. Negative 3 times x gives me negative 3x. And negative 3 times negative 3 gives me minus 9. From here, we're going to combine our like terms. We'll have x squared. 3 minus 3 just gives me 0, minus 9. I want you to go ahead and do the same thing with x minus 8 times x plus 8. And then I want you to describe what happened to the problem whenever you multiplied. What happened to this one and what happened to this one. All right, so hopefully you took the time to do that. You should have gotten, once you multiplied, x squared minus 64. And what I was hoping that you would notice that both of these are actually binomials, okay? And there's only an a and a c term. There's no b term in the middle, okay? And that's because, like for here, the 3 and the negative 3 cancel each other out, okay? So that is called the difference of perfect squares, okay? So to factor difference of perfect squares, it's actually a pretty easy process. It's a lot shorter than the factoring process that we learned about yesterday. Okay. So the first thing we have to notice is that both terms are perfect squares. Okay. So a few examples are here. X squared is a perfect square. 4, 9, 16. If we look at these, 9 and 64 are both perfect squares. Notice that both terms are perfect squares and they are being subtracted. Remember, difference is a fancy word for subtraction. Okay, so notice that both of these have a subtraction sign in the problem. Okay, if you get an addition sign, it's actually not factorable. That's called the sum of two squares. Okay, and that's actually not factorable. Okay, so since they're being subtracted, okay, we're good. So we have x squared minus 49, for example. X squared and 49 are both perfect squares, and they're being subtracted. So now we're going to find the square roots of both terms. So the square root of x squared just gives me x. And the square root of 49 is just plus or minus 7, right? Because 7 times 7 is 49. And then we're just going to fill in our parentheses accordingly. So the x is going to go up front. And then we're going to bring the plus 7 to the first and the minus 7. All right, and that's all we have to do. Pretty straightforward process. So looking at the next one, okay, we have x squared minus 9. Okay, both of these are perfect squares, and they are being subtracted. We see that in the middle. Okay, so for this one, we're going to go ahead and just take the square roots of both terms. The square root of x squared is just x. The square root of 9 is plus or minus 3. So then we just have to fill in our parentheses. So we'll have x and x. We have our plus 3 and that negative 3. So we're going to bring both of those down. We'll have plus 3 and minus 3. Oops, not 7, 3. Okay. So really, find those two pieces, plug them in. Now this only works if you have two perfect squares. All right. Let's look at number 2. Now, we haven't really talked about this, but someone remind me or think to yourself, okay, what is the very first thing we always have to look for when we factor? You should be rolling your eyes and saying the greatest common factor. We know. We always look for the greatest common factor first. And 3 and 75 have a greatest common factor of 3. So we're going to take out the 3, and then we'll have x squared. 75 divided by 3 gives me minus 25. And then notice both of these are now perfect squares, which is great. So that means it's going to be easy to factor. So when the 3 goes up front, we're going to set up our parentheses. The square root of x squared is just going to give me my x's. The square root of 25 is plus or minus 5. So plus 5 and minus 5. That's going to be it. All right. So another special type of quadratic is a perfect square trinomial. And we've actually already worked with these. So this is more of a little bit of a review little section. Okay, so on the first one, what happens when I factor the following? So we need to think what's going to add to give me 6, but multiply to give me 9. Okay, so hope you're sitting there thinking of those two numbers. What adds to 6 and multiplies to 9? That's going to be 3 and 3. So then whenever I rewrite this, I'll have x plus 3 times x plus 3. Now, with the perfect square trinomial, since they're both the same thing, we want to make sure we're writing this as x plus 3 squared. Okay, since they're both the same thing, we want to make sure we're doing x plus 3 squared. All right, I want you to go ahead and try the next one. We have x squared minus 6x plus 9. So go ahead and do that one for me. Okay, so I want you to think what's going to add to give me negative 6, but multiply to give me 9. So I want you to go ahead and try that one for me now. All right, so hopefully you took a few seconds to try that one for me. Okay, you should have gotten negative 3 and negative 3. So then when I write this, I'll have x minus 3 and x minus 3. But we have to be writing these in our special notation. So it's actually going to be x minus 3 squared. Now, I'm not going to be like throwing a big fit if you forget to write it this way. Okay, but just know that this is the most simplified and honestly the best way to write this. All right. We are actually, because these are just a sign of the same examples, okay? So we're actually going to go ahead and stop there so that you can move on to the next video. Yes, you need to watch the next video. It is also short. You can do it. And then you can move on to your homework, okay? Other than that, you're good to go.